So welcome back to my YouTube channel. Today in this video we'll be solving a very beautiful problem of a GFG. So it is a vertical sum. So first let's read out the problem. Given a binary tree having n nodes, find the vertical sum of the nodes that are in the same vertical line. Return all sums through different vertical lines starting from the leftmost vertical line to the rightmost vertical line. Now here in this question, they are saying that we need to find vertical sums and we need to output the answer like this. Means you have to find the vertical sum from leftmost to the rightmost, right? So basically this is the question. So here you can see that the this is the leftmost level, so 4, then 2 is at a -1, 1, 5 and 6, they all three are at the 0 level. So the summation of 1, 5 and 6 would be 12, and 1, 3 and 2 at 7. So this is how 4, 2, 12, 3 and 7. This is our output. Now our main question is how can we solve this problem? So let's understand this. So what we can do here is we can initially give a vertical level to the root, right? And then we will explore its children. Like for example, let give the vertical level number to the root be 0, right? So its left child, let's give it a one less, and to its right child 1 plus, right? So similarly, same process we will follow for its subsequent children's, right? So again you will come to the 2, so 4 would be -2 and 5 would be 0, right? Similarly for the 3 also, left child 0 and right child +2. So what is the benefit of doing this? So you can see that, see, I know the level of a root is 0, but I don't know that which all other nodes would have the same level as that of root, right? And similarly for other one also, here it is -2. Maybe if we extend this tree further, then we might have got the another node whose level is would be same as that of 2, right? But as for this just for this example, we can see that 1, 5 and 6, all of these three nodes have the same level, that is a 0, right? So what is the benefit of doing this? So if we assign a numbers to the particular node, vertical level number to the particular node, then we could easily able to uh, answer them. Means we can increment in our map. So like for example, we can see here that 0. So in 0 we can create a map, right? In map we can store it, like at 0 there is a 1, then 5, then 6, right? So we can easily just add it, all of them. Similarly for the -2 there is only 1, for -1 there is a 2, 1, 3 and +2 there is only 7, right? So this is our output. Now let's just have a look at a code so you would understand even more better. So yeah, so I have used here BFS. You can use BFS to solve the same problem. And later on, I'll also discuss what is the time complexity of this approach. So first of all, I have created an order map, and I also created a queue, right? So initially the level of root is 0. You can see here my level of root is 0. And now I'll also maintain a mean and max level. I will tell you later why I'm creating this particular variable, these two variables. So I'll explain you later in this video. So don't worry, stay tuned with me. So initially we'll check first queue is not empty. Okay, then I'll pop the front element from the queue, and then you just forget about this first two line, and then you can see here that in the map I am storing every level key, right? And I am also incrementing, so that because I want a sum. And similarly what I'm doing is, if temp left is present, then push it in the queue. Similarly light is present, then push it in queue, but make sure to decrement and increment the level, right, according to their child's. And finally, I will returning the answer. Now question comes, why I have used this minimum level and maximum level. So the main reason is, see, if I would have not used this mean level and max level, then how I should know, how I should know, I should have known that means actually question says that you have to answer it from leftmost vertical to the rightmost vertical, right? And in unordered map the keys are stored in random fashion, they are not ordered, right? So for ordered, I want my answer in order, so that is why I am maintaining this mean level and max level. And later on, so that I can iterate over these levels, and these levels are nothing but my keys only, right? So you can see that I am iterating from I is equal to min level to the max level. So you can see in this example, my mean level is -2 and my max level is +2. So I can iterate over this my map, and in the map it is always guaranteed that all the levels, means all the number between this mean level and my max level would present in my map, including this both number, right? It would never happen then that any particular even single number would be missing. This should never be the case, right? Each and every number between mean level and max level will be present in our map. So yeah, this how we can solve. And if you don't want to use this mean level and max level, you want to get rid of it, so you can also use only map. But just to make my time complexity O big O of n, I want to solve this problem in big O of n. That is why I have make use of this particular mean level and max level. Otherwise, if you want to solve it using normal map, you can also solve it, right? So now coming to its time complexity and space complexity. So time complexity, here we can see that since I am only using this particular map, and map takes constant time to store any elements. Specifically, I'm talking about another map. So yeah, that is it. And time complexity is also my big O of n. Why? Because I am using this particular QU, and also I am storing my answer array. So yeah, that is it. Still, if you have any doubt, you can ask me in the comment below. And if you really enjoy this video, you learn something new from this video, so I would encourage you to like it, subscribe to my channel if you are new, hit the bell icon, and also share with your friends. Thank you.